Okay, we're going on now to topic 3.8, additional exercises. And I see I need to trim this a little bit. Yes, that's better. So, again, section 3.8, business and economics applications. We just did these in the PowerPoint, break-even analysis and supply and demand. Now what we're going to do is take a look at our vocabulary terms here. And there are 7 words, and we'll give you a moment to see if you can figure it out. Remember, you can pause the tape, or you can see after I put them in. So if you watch the PowerPoint, you'll see that these are pretty easy. So the amount of money a company spends to produce a product is its total cost. Makes sense. The amount of money a company takes in is total revenue. And the difference between the two, if it's in the plus, it's profit. If it's in the minus, it's loss. Here they're asking for profits. When the profit is 0, you're at that point of intersection, which is the break-even point. The demand function describes the quantity consumers will want to purchase as a function of price. I could recall years back when they had the flat screen TVs coming out. And for a 28-inch, I paid like $1,200. Today, 28-inch is, I don't know, $300? Depending on the quality and the brand. Oh, that's a lot difference. But again, supply and demand. The supply function describes the quantity sellers. I think we did that one already. Or it's interesting. Okay, and then the point where they sort of balance out, that's the equilibrium point. Remember, you're going to have a graph that goes up. That's the demand. And then the supply. And right there in the middle, where they intersect, is the equilibrium point. Okay, let's continue. We'll work out some of these here. Here they have it set up nicely for us. And remember, this we said is a y, and this is a y. So we're just going to do 35x equals 15x plus 20,000. We subtract 15x from both sides, and we get 20x equals 20,000. Divide both sides by 20. So, x equals, well, let's see what they want us to ask. Oh, what would be the total profit? Well, it's going to be profit function is equal to revenue, which was 35x minus the cost, which was 15x plus 20,000. That's that formula. Notice as we distribute the negative, this becomes negative and this becomes negative. We transpose that to the other side, and that becomes negative on this side. So our answer is negative divided by a negative. So it comes out to be 10,000 units and at the profit of $35,000. Wow. Okay. Well, that's our break-even point. All right, let's go on to number 9. Number 9 is going to be very similar. It's just that 32x equals this. Remember, these are y. And it's going to be this minus that. And for number 9, for part B, the answers are going to be 12,500 and $400,000. Wow. We're talking about big money here. Again, C is our cost. This is our fixed cost. This is our variable cost. And then this is the revenue that we take in $32 for each item we sell. Again, in figuring out the profit equation, it's going to be P of X is equal to revenue minus the cost, which is 32x plus 65,000. And our break-even point is at this many units and at this amount of sales. Okay? Well, let me work the next one for you. Again, the profit equation would be this: 140x minus 115x plus 300,000. So in following this one all the way through, there's our y equals y. We're going to subtract 115x from both sides. That gives us 25x. We divide both sides by 25. That'll give us 12,000 units. And then 12,000 units at $140 a unit, that's going to give us, ooh, this is big time here, $1,680,000. That would be our break-even point. This would be the amount of income from revenue. This is the number of units. And once again, how did we find it? Well, we equal this to this, and we solved for our number of units. Then if this is our number of units, we times it by what we get for each unit sold. And this is big bucks here. Okay, let's go on. All right, this one's a little different. It's supply and demand. And remember, if we were to graph these, it would look something like this. That one line would be like so, the other line is going to be like so, and we're looking for the point of intersection. And again, we could substitute a y for this and a y for that. So we're getting 100 minus 5p equals 65 plus 2p. Want to keep our p's positive, so I transpose this, becomes a positive 5p. So this adds up to 7p. Transpose that, and that adds up to 35. Divide both sides by 7. I get p equals, so the price will be $5. And what will the demand be? Well, we know that p is 5, so we put a 5 right where the p is. So this will be 100 minus 5 times 5. That's what p is. That's 100 minus 25 is 75. So our demand is 75. So at $5, we will sell, this is just, of course, a hypothetical, 75 items. This is your point of equilibrium, where these two lines are intersecting. Now, as you may realize, I don't do them all, because that would make the tape very long, but we want to be sure you know how to do them. So let's just set this one up. It's going to be 5500 minus 40p equals 3000 plus 10p. Notice this is negative slope, so we're going to bring that over to this side, get 50p. Subtract that from this side and get 2500. Divide both sides by 50. And we get p equals 50. Notice this cancels out, and this goes 50 times. Now, how do I get my demand? Well, I put in this original equation, p right there is 50. So our p is 50. So it's 10 times p is 500 plus your 300 gives you your 3,500. So this is your demand, this many units at $5. And this one works out exactly the same way. You equal your equations. P is 75. If you put 75 here, multiply it by 26, add this to it, you get that. Okay? You could also put the p in this equation. Okay. Number 15 is done exactly the same way. The price is $12. The demand would be $4.18. This is your equilibrium point, where if this is the price, you could expect to sell this many units. And by the way, this is a formula that's used by a lot of businesses when you go to the mall or any other place. Let's go on now to our last few examples here. Let's see what they're asking us. So, furnished room is planning. Well, I guess that's the name of a company. to add a student desk to its production line. The fixed cost for production is this, the variable cost for each desk is that, and the revenue from each desk is this. Find the following. Okay, well, we did one like this in the PowerPoint slide, so let's do this one together. So for A, they want the cost function. Now, we could put the fixed cost first, but I like to do it the other way. So to make each desk, it's 350 for each desk, and then this y-intercept is the fixed cost. Okay, now the revenue, we're going to sell each desk for $600. Now, if you've ever had a business, you have to sit down and figure out, what are you doing? I had a little photography business when I was actively teaching on the weekends, well, teaching during the week, photography business, and I had to sit down, what were my costs, and buy the film, take it to the developers, have the prints made, and there's going to be a little something, and I had to figure out a little formula like this. Okay, the total profits will be profit of X is such that it's equal to revenue minus this one. And I could take away the parentheses also, but both of these become negative. Alright, so for letter D, the profit or loss from the production of 1,000 desks. So we put 1,000 there, 1,000 there, and do the math, and it looks like it's going to be, for that many, it's actually going to be a loss here. If you only sell, you're going to sell for D, 100 desks, believe it or not, you would have a loss of $165,000. No, I wrote that incorrectly here. Okay, I paused the tape so it wouldn't be so long. But if you sell just 100 desks, then the graph would be such that you would be below the break-even point, and that would indicate a loss of $60,000. So if you put 100 in there and 100 in there, since this is going to be larger, it's going to be a loss of 60,000. But if you put 1,000 in there, you actually have a profit of 165,000. Now, what's the break-even point? Well, we know it has to be more than 100, and of course less than 1,000. And by equaling this equation to this equation, we find that X is 340 desks. And if you put 340 for X, that will give you $204,000. That's the break-even point. So you have to take in this much money for selling this many desks to break even. And we've worked that. All right, let's go on. Okay, and working the second part here of number 17, this is demand, this is supply, one equation equals the other, And I have the work here. We're going to solve for P, and P equals this, which is what we have there. Now, if this is our price, and it's price times number of units that need to be sold, so this is revenue, this is fixed cost, variable cost. Solve this equation, subtracting this from both sides, dividing this, we get approximately 480 units. Okay, I've kept this down to about 20 minutes down here, and that is section 3.8. And good luck on this.